Hi everyone. Let's take a look at these word problems that have to do with exponential functions, and then we'll use logarithms to solve them. So when I'm looking at number 11, it says a new car is priced at $37,000. It is expected to depreciate, that means it's losing value, at a rate of 12% per year. So remember, for all of these equations, we're kind of taking this approach to them. And this is from back in the beginning of the chapter, y equals a times b to the power of x. A is our initial value, so in this case that would be the 37,000. The b value is what you're growing by, and I use the term growing loosely because in this case we're not actually going to be growing, we're going to be decreasing. But to decrease by 12%, what we actually want to multiply by is the percentage that we're keeping. So when I'm depreciating by 12%, I'm actually plugging in b equals 0.88, and I got that from doing 100% minus 12%, okay? And that would really be 88%. So my equation is going to look like this. Y equals 37,000 times 0.88 to the power of x. Okay, that's my exponential function. And then if I want to know when will the value be 24,900, I'm going to put that in for y over here. Okay, so I wanted to show the setup separately, and now I'm going to move over here, and I'll actually show you the math for solving this thing. So let me just rewrite that equation quick. So that was 24,900 equals 37,000 times 0.88 to the power of x. Okay, so as far as the solving part goes, we want to isolate the exponential piece. We want to get this by itself, which means we need to get rid of that 37,000. So the very first thing I'm going to do is divide both sides by 37,000. Okay, and let's see. So 24,900 divided by 37,000 gives me 0.6729. I'm going to jot that down to just a couple of decimal places. So I'm going to do 0.673 maybe. But you'll see in just a second, I'm going to try to keep as much of that decimal in my calculator that I can, so I'm not like losing a whole bunch of it due to rounding. So now I have equals 0.88x. Sorry, 0.88 to the power of x, I should say. Now, this is the new piece from this lesson. Anytime I have an x up in an exponent like that, the way I'm going to get it down is by taking a log on each side. And technically, I could take any log that I want to, but I usually choose the common log because my calculator will do that for me. And the reason I like taking that step of taking a log on each side is now I can take this exponent and move it down in front of this expression. So now I'm really looking at log of that decimal that's still sitting kind of safely over in my calculator there equals x times log of 0.88. And now that that's multiplication, I can get rid of it, or I can get it by itself using division. So I can divide both sides by log of 0.88. Okay. So in my calculator here, this is where I'm keeping this entire decimal. So I'm going to do log of this by using the answer button, okay, to bring down the entire decimal, divided by log of 0.88. And I get 3.098. Again, I'm going to try to keep that in my calculator as much as I can. So I get 3.098 equals x. Now, what I want to point out is this is your answer. This is your time, right? Your x always represents your time. So this is a number of years. I don't have room after it. So this is the number of years. The question said it wanted my answers in terms of years and months. So my years would be the 3 years, right? Now the question is, how many months are represented by this 0.098? Okay, so what I can do, I want to get this decimal, but where the 3 is gone. So I'm going to subtract the 3 so that I have just the decimal left. And then this represents like your months. If there's 12 months in the year, I can multiply this by 12 to see how many months this actually represents. And it looks like it represents just a little bit more than 1 month. So 3 years and 1 month. And that's when my value will reach that 24,900. Okay? Okay, let's move on to that next one. So this one is a population growth one. Population of Grand Rapids was approximately 196,000. That's going to be my A value. And has been growing at a rate of 1.2% per year. So this time we're dealing with population growth. Remember back here we were dealing with depreciation or decay. So we subtracted from 100 to get this number. Here, because we're growing, we're going to add to 100. And sometimes we mess up the decimals on these. So I'm going to put this in my calculator, even though mathematically I don't think you need to. This is what I'm doing. 100% plus 1.2%. So this is the number that I'm focused on. And then remember, because it's a percentage, I want to move that decimal over 2 to the left. So it's going to end up right between the 1 and the 0 there. So my equation is going to look like y equals, where's that number? 196,546 times 1.012 to the power of x. And x will be my number of years. Okay, so once again, let's head over here to number 12. 200,000. And then there's the rest of my equation. So 196,546 times 1.012 to the power of x. And this one's actually going to work very, very similarly to number 11 here. I'm going to start by dividing out that number in front. This division, I ended up with 1.018. And again, that is a rounded decimal. Okay, so there's the decimal I actually got when I, oops, sorry, can't see that. That's the decimal that I actually got. And again, I'm going to try to keep that decimal in my calculator for as long as I can. I once again have an x up in the exponent, so I'm going to move that down by getting a log on each side. And moving the x down in front. So now I'm looking at log of 1.018 equals x times log of 1.012. I can get rid of this with division. And then here I'm going to go log of the answer, so I can keep that whole decimal here, divided by log of 1.012. And I end up with 1.46. And that's just equal to x here on the other side. So again, this is talking about the number of years. In this question, it told me specifically that we were starting in 2018. If we're assuming that this rate or that this value came from the beginning of the year 2018, which it didn't technically specify, but if this came from the beginning of 2018, then 1 year would take us to 2019. And then that extra 0.46, that would be like the beginning of 2019. This would take us about halfway through. So we would expect like halfway through 2019, we would reach that value. Okay. Now, if this value came from the end of 2018, then my answer might change a little bit, right? Because if my answer, or if this original number came from the end of 2018, then my 1 year would take me to the end of 2019, and I would actually be halfway through 2020. So, and I'm just going to verify here. Yep, it didn't give me that information. So I would actually probably take 2019 or 2020 here as an answer, because they weren't super specific about when in 2018 that value was. Okay, let's keep going. Number 13. Okay, so number 13 is a good one. It says Jim owns a rare sports collectible. Its value is increasing at a rate of 0.75% per year. So there's my B value, right? And again, if you need to, you can do 100 plus 0.75. Whoops, not with the zero. So you can see that decimal there. Then I'm going to slide my decimal point over. And so this means I'm going to use a B value of 1.0075. That one's going to be a tough one. Okay, B value is 1.0075. And then it says he decides he will bank his whole retirement on selling this item once the value doubles. So you will notice that this question does not give you an A value, right? It does not give you the initial value of the item. Okay, the good news is here, you're going to be able to kind of make that up. And it doesn't matter what you make up, and I'll show you that in just a minute. But I think the easiest thing to do would be to decide that this item is going to be worth $1. Okay, so when I write my equation, I'm going to say the initial value is just a 1. Here's my B value of 1.0075. And then we're going to the power of x. Okay, and then if I want to know when my value doubles, what I will be doing is putting a 2 in here. Because to go from 1 to 2, that's making my value double. Now, you're probably thinking this doesn't make a whole lot of sense, right? Because the chances of him banking his retirement on something going from $1 to $2 does not sound very smart, right? Well, we know that the value right now is probably not really $1. But the way exponential growth works, it will take the same amount of time to go from $1 to $2 that it would to go from $1,000 to $2,000 or $10,000 to $20,000. This is just the simplest form of this equation to work with. Okay, so if you had wanted to put $100 and $200 here, you certainly could. Your first step, just like we've done in all the other ones, will be to divide by this number. The reason we like this 1 here is because we don't really have to divide by it. We don't care about a 1 sitting there, so we can just jump right into that next step. Okay, so when I attempt this one, let's see. I'm just going to go over here. This is number 13. And again, I'm just sticking with 1 and 2. When it gives you problems like that where you get to pick, I always put 1 in as my initial value. And really, because it's a 1, I'm not even going to worry about writing it in there. Okay, I can just start right with this. And again, this is kind of like a 1 sitting here, but if I were to divide by 1, it wouldn't matter. So I can jump right into taking a log on each side, moving this x down in front. Okay, and we end up with log 2 equals x times log of 1.0075. Let's divide by that log. Okay, so log 2 divided by log of 1.0075. We end up with 92.76. So let's gain some perspective here. I guess it doesn't really matter here, but I'll follow my rounding rules. What we just found is that to go from $1 to $2, it's going to take approximately 93 years. So if Jim is waiting for this thing to double in value before he retires, it's going to be an awfully long time before he retires. Just want to make sure his name was actually Jim. Okay. And again, this would be the same thing if the value right now was $1 million and he was waiting for it to turn into $2 million. We would run through these calculations and we would get the exact same thing. Because no matter what you put here and here, if your first step is to divide by this number here, this is always going to come out as a 2 if you're doubling. Okay? Okay, so those problems are pretty common. You'll see those again for sure sometime. Next up is our favorite, half-life. So radioactive element has a half-life of 17 months. We're going to ignore that number for right now. A mass of 130 grams, so that's our initial value, has been observed for a period of time and currently 45 grams remains. How long has the substance been decaying? All right, so half-life is still going to set up just like this. It's still going to set up with this y equals ab to the x. I know my initial value is 130. What's not really listed specifically here, but it's implied when I talk about half-life, is that my b value is going to be 0.5 or 1/2. Whoops, not 0.15, 0.5. And then the way I deal with this, the way that I make it work so that it's every 17 months, is instead of just putting an X up here like I have in all the others, because all the others have been happening like every single year, right? If I want to break this up over a number of months, I'm going to do X divided by 17 up here. And what that's really doing is taking all of those months and grouping them into groups of 17 so that I can figure out how many times I need to cut in half. And then what I'm going to do is I'm going to take this 45 and plug it in for y, and then it's going to work just like all the other ones we've done. So let's take a look here. 14. Currently have 45 grams. We started with 130 grams. Half-life of 17 months. Looks like that. So we didn't do this in 13 because we didn't need to, but in all the other ones, the first thing we did is get rid of this number right here, right? So let's divide by 130. Okay. 45 divided by 130 gives me, again, a messy decimal. Messy decimals are really common with these. So 0.346 is equal to 0.5 to the power of x over 17. Now, this exponent is a little messier than all the others, but that doesn't really change our process, right? We have x up in the exponent, so we're going to get it down by taking a log on each side. And what I'm going to do is take this entire exponent and move it in front of the log. So now I'm looking at log of 0.346 equals x over 17 times log of 0.5. I'm still trying to get this thing by itself, so I'm going to divide by that log 0.5. Just like I've done with all the other ones, when I do this calculation here, I'm going to try to keep that whole decimal, right? So I'm going to do log of the answer from above divided by log 0.5. So I get 1.53-ish, again, equals x over 17. Now, in all the other ones we've done, at this point, we've essentially been done, right? That's been our answer. But for this one, because this is division, my next step is going to be to multiply by that 17 to get rid of it. Okay. And I'm going to just do answer times 17 to keep that whole decimal in there. And we end up with about 26 months. Okay. If you wanted to convert that into years, I mean, you don't really have to, but this would be like 2 years and 2 months. But I'm fine with an answer just in months too. Okay, one more of these to get through, and I think this last one is a throwback to compound interest. Now, this one isn't going to look like this originally. When we first set this one up, you're not going to see this, but it is one of these problems. The compound interest formula is just a specialized version of this formula. So let's start out by seeing if we remember compound interest. Compound interest is P, and sorry, I should have read through this problem first. If we're investing $1,500, that's my P, right, my principal. 3.2% interest means my R value if I move that decimal over, is 0.032. Compounding semi-annually means my n value is going to be 2 because that's twice a year. And then my bet is we're trying to solve for t here. So if I use those values to plug into the compound interest formula, it's P, so 1,500, 1 plus my R, 0.032, divided by n, which is 2, and then all to the power of 2 times my time, okay? That's what my compound interest formula would look like. If you notice, this thing in parentheses, that's really your B value. This is A, right? If we're going back to that AB to the X thing, this is A, not the same as that A, but this is A. This is B. That 1 comes from the fact that we're growing, right? So just like up here where we put a 1 in front of this to make it grow, that's what this 1 is doing. This is the percentage, but we have to divide it by 2 because of the compounding, and so that's why this looks a little more complicated. So what I'm going to do before I start anything else is I'm going to take just this part and plug it into my calculator so that I can get just a single B value. So I'm going to go 1 plus 0.032 divided by 2. Okay, I'm just doing that part that's in parentheses. 1.016. So now this is going to look a lot better. 1,500. 1.016, and then to the power of 2t. By the way, what we just did there was found annual yield, if you remember when we did that, but don't stress about that right now. I guess technically that's not truly annual yield. I misspoke, so ignore me. Okay, so now let's take this, and this is where we're going to take that 1,800 and plug it in for the A value. So, sorry, more pens than I know what to do with here. So for 15, what was my number again? 1,800 equals 1,500, 1.016 to the power of 2t. And from here, this is going to look like all the other ones that we've done. Okay, so I'm going to start by dividing by that 1,500. So 1,800 divided by 1,500 is 1.2. Oh, finally, a nice clean decimal. So this one actually did come out, if you didn't do this one with me. Came out to just perfectly 1.2. All right, log on each side. Bring this 2t down in front. And so now we have log of 1.2 equals 2t times log of 1.016. I don't know why I put parentheses there. I don't need them. Okay. I'm going to divide by that log to get this thing by itself. And then let's do this calculation. So log of 1.2 divided by log of 1.016. And I end up, sorry, you can't see that, but I end up with 11.48. So notice that's equal to 2t. So then at this point, I want to go in and divide by 2 on each side. And I end up with t is about equal to, let's take that and divide it by 2, 5.74. So if someone were to ask me this question, you know, how long will it take for me to go from $1,500 to $1,800, I would probably say something like almost 6 years. It'll happen sometime during that 5th year, but it'll be close to year 6 there. Okay? Okay, that's it for these word problems. Hopefully they looked scarier than they actually were. Hopefully you didn't find them too terribly difficult. Please let me know if you have questions on any of them. I'm happy to walk you back through any of the steps that you may have missed. All right, thanks a lot, guys.